If you stand far away from the graph of a power function, then they behave predictably. The shape and direction of a power function is determined by the coefficient and whether the power is even or odd. And, in general, the overall shape of a graph as x values grow extremely large is referred to as the end behavior. To describe the end behavior of power functions, we'll be using the following notation. X approaches infinity means that our x values are growing extremely large. X approaching negative infinity means our x values are growing extremely large in the negative direction. And a quick reminder, the square of a negative number is always positive. In the first case, let's assume k is greater than 0 and n is even. Then, as x approaches infinity, we have that f of x is also approaching infinity. This is because x raised to the n is equal to x times x n times. And as x approaches negative infinity, we also have that f of x is approaching infinity, where f of x is still approaching positive infinity because x raised to the n can be rewritten as a negative number raised to the second. Now let's look at the case when k is greater than 0 and n is odd. As x approaches infinity, we also have that f of x is approaching infinity, since our function is essentially taking a number and raising it to the nth power. But now, as x approaches negative infinity, our function f of x will be approaching negative infinity. And this is because when we raise a negative number to an odd power, what we get out is a negative number. For the cases when k is a negative number, by transformation of functions, this is going to correspond to a reflection along the x-axis. For example, when k is less than 0 and n is even, as x approaches infinity, we have that f of x is approaching negative infinity. And as x approaches negative infinity, f of x is also approaching negative infinity. In the last case, we have our coefficient k is less than 0, and n is odd. As x approaches infinity, then f of x is approaching negative infinity. And as x approaches negative infinity, f of x approaches infinity. Now let's apply what we just saw in the previous two slides and describe the end behavior of the following power functions. In part A, we're given f of x is equal to x raised to the 8. Here, the coefficient k is equal to 1, and our power n is equal to 8. Therefore, we have an even power. And since our coefficient is positive, we're going to have a function that opens upward. So the general shape of our graph looks like the following. In part B, we're given that g of x is equal to a negative 5x raised to the 4th. Here, we're given that the coefficient k is equal to a negative 5, and our power n is equal to 4. Since the power of our function n is an even number, the shape of our graph is going to look like a U. And our coefficient is negative means that our graph is going to open downward. Therefore, the general shape of the graph is given by the following.